With the chain of custody started, we begin the process of evidence acquisition, preservation, analysis, and reporting. In this unit, we will demonstrate one or two tools for each step to help you understand the process. In the later units, we will cover more technologies in detail for different operating systems. In computer forensics, as we mentioned earlier, we focus on digital data. This includes any information either in process, stored, or in transit in the form of files, metadata, like permissions, and deleted data. From this data, investigators will gather information about individuals, determine what happened, construct a timeline, and discover malicious tools or exploits used by the attacker. Different cybercrimes may lead to different digital evidence. For example, cyber stalkers may use emails to harass their victims. Computer hackers usually leave malware, backdoors, and other activities in system log files. Child pornographers have digital images, possibly hidden images, stored on their devices. Acquisition includes acquiring both volatile and non-volatile data. Volatile data requires power to maintain the stored information, like data in memory. Data stored on hard drives is a common example of non-volatile data. We always acquire volatile data first because they're short-lived. To acquire volatile data, for example, network interface, we simply run a command such as ifconfig or ipconfig. Please be notified when working on collecting evidence from a suspect machine, you have to make sure all output will be redirected outside of the suspect machine, because otherwise you are tampering data. In addition, you have to make sure unwanted data is not retained on a drive of receiving machine. We usually call the receiving machine as a forensics machine, to avoid danger of residual data on your target drive corrupting your evidence. In a common practice, you will sanitize the evidence drive of the forensic machine before data acquisition. The methods of wiping a hard disk will be covered later. A bit stream copy gets every single bit of every byte on a device. It performs on the drive level, not on a file level, ignoring the end-of-file marker. Therefore, this process is often called a hard drive imaging, bit stream imaging, or forensic imaging. While commands such as cpcopy, tar, cpio, dump, restore only copy file content, stopping at the end of file marker, the bit stream copy will copy every bit on the drive, including deleted data. Both DD and FTK imagers are well-known forensic imaging tools. In the next video, I will try to demonstrate how to use FTK imager to create image, and we will cover DD in a later lecture.